Okay, finding unknown angles. So when we find, or when we use the trig ratios, or when we have been using the trig ratios, I should say, we've been using them to find missing side lengths. But that's not always the case. You can also use them to find unknown angles. So say, for example, that we knew that this was equal to 3 and this was equal to 4. We could find what this angle was by using one of the trigonometric ratios. But we have to do a few steps a little bit differently. Instead of just using the flat-out trigonometric ratios, we have to use these inverse ratios. So inverse sine, which is a sine with a little minus 1. Inverse cosine, which is cos with a little minus 1. Or inverse tan. Now, the reason I bring that up is because with that, we need to, or we have to press a few different buttons on our calculator to actually solve these problems. So before we continue, actually no, you know what, we'll continue on and I'll show you how to do that when we get up to those problems. So examples, question 1 to 2. So what we're going to do to begin with is we're just going to convert some degrees into degrees, minutes, and seconds, okay? Even though it says degree, we're going to do degrees with an S, okay? So the cool thing about when we're putting a degree or a decimal place degree into our calculator, it's automatically going to put it in degrees, minutes, and seconds for us. So 40.8 degrees is the same as 40 degrees and 48 minutes. Okay. We can do the same with 40.125 degrees. So the decimal changes into the minutes and seconds. So this is 40 degrees, 7 minutes, and 30 seconds. Last but not least, we have 40 and a third. Now you need to make sure you hit shift and then the fraction to put a mixed numeral in. Otherwise, it won't do it properly. What it will do is it will think that you're doing 40 times a third, which is very different to 40 and a third. 40 degrees and 20 minutes, because if you think about it too, a third of an hour, or a third of an hour is 20 minutes, 20, 40, 60, so 1/3 is 20. And so that's it for that question 1 to 2. So that's all you need to do. Question 3, calculate each of the following to the nearest degree. So basically all we have to do for this one is put it into our calculator as well. Now, to put these in, it says sine of -1, so it's the inverse sine. So what we're going to do is we're going to hit shift and then we're going to hit sine. As you can see, it puts the sine -1 in for us. So 0.3907, close off the bracket and hit equals, and we get 22.999, etc. Okay, I'm going to hit the degrees, minutes, and seconds, and I want to round it to the nearest degree, so it's 22 degrees 59, so it's going to round up to 23 degrees. Okay, tan of a half, so we're going to put in shift tan, so tan of -1 of 1/2. Okay, close the bracket and hit equals, degrees, minutes, and seconds, and we get 26 degrees and 33 minutes. Remembering that with degrees, minutes, and seconds, if a minute is above 30, okay, then it rounds up. Or if it's 30 and above, it rounds up. If it's below 30, it rounds down. So this one is 33, so it's above 30. So we're going to round it up to 27 degrees. Okay, example for question 4. Find the value of theta or phi to the nearest minute. So just a different Greek letter in this case, okay, but it still serves the same purpose. So what we're going to do is we're going to be using our Sohcahtoa to find our values, okay? Because we are doing some trig again, okay, and we're using the 3 ratios, so we need sine, cosine, or tan. So we need to work out, well, which one of these is the triangle using. So we'll start off with this one here. The angle that I've been used or indicated to use is this one in the corner. We've got an opposite and adjacent in relation to that corner there. So which of my 3 uses O and A? Well, it's TOA or tan. So I'm going to write tan of theta, or tan of phi in this case, is equal to. So I'm just going to jump straight in and do it. So remembering that sine theta is equal to O on H, cos theta is equal to A on H, and tan theta is equal to O on A. Okay, so tan is the opposite, so 4.2 over 8.3. Now, we don't care what tan of phi is equal to. What we do care though is what the individual letter by itself is, okay? So to remove the tan from the left-hand side, what we're going to do is we're going to use that inverse. So effectively what we're doing is we're just going from one step to the other by saying, okay, to get this to the other side, okay, to get that to the other side, we're going to put a tan -1, okay? And that's going to basically cancel that one out. So once we do that, we're going to put it into our calculator. Okay, so shift tan 4.2 over 8.3. Close off the bracket and we get 26.84. But we want the nearest degree, so it's going to be 26 degrees and 50. So 26 degrees and 50 minutes. Okay, number 2. So here's my angle in here. We've got an opposite over here, and we've got a hypotenuse over here. So O and H, well, O and H is for sine. So sine of theta is equal to my opposite value, which is 5, over my hypotenuse, which is 8. So just like that. Now to get the theta by itself, we're going to do the sine inverse. So sine of -1, and we're going to put what's on the right-hand side in the brackets. So theta is equal to sine inverse of 5 over 8, close the bracket off, hit equals, and we get 38 degrees and 40 minutes. So that rounds up to 38 degrees, 40 minutes and 55 seconds. So it's going to round up to 38 degrees and 41 minutes. Remembering that seconds is the 30 split. So if it's 30 and above, it rounds up. And if it's below 30, it stays the same. Now for this one, we've got a hypotenuse and we've got an adjacent. So H and A. And so that leaves our third one, our cosine, CAH. So cos of theta again is equal to adjacent, which is 9, over hypotenuse, which is 12. To get the theta by itself, we're going to do the cos inverse this time. And then everything on the right-hand side is going to go inside the brackets. Theta is equal to, putting it into our calculator, shift cos, and then 9 over 12. Okay, hit equals, and then we're going to change to degrees, minutes, and seconds. And it's 41 degrees, 25. 41. I'll do it properly. 41 degrees, 25 minutes. Just like that. Okay, so we've got a few more examples for this one. So, I did the same thing, didn't I? Because this question is just asking us find... Okay, so that's basically what you need to do for question 7. Actually, what you need to do for question 4 is just decide which one you need to use. I've accidentally swapped around question 7 and question 4. So this should be question 4, which says which trigonometric ratio should be used to solve for the unknown, which should be, okay, opposite and adjacent, so we're going to use tan of phi. This one is opposite and hypotenuse, so we're going to use sine of theta. And this one is hypotenuse and adjacent, so we're going to use cos of theta. What question 7 actually is to do that. So when you get up to question 7, actually watch what we do for question 4. When you do question 4, I mean, like, you know, it's just picking which one we're going to use. So question 5, and I think I made this mistake the last time I tried to record this video. So when we do question 5, what we're going to do is we just need to, okay, find theta by itself. So to do that, we're going to do cos of the -1, okay, of 0.3907, okay. I'm going to put that into our calculator. So shift cos 0.3907, close it off, hit equals, and we're going to get 67 degrees. Okay, sine of theta, so same thing, do the inverse. So theta is equal to sine of -1 of 0.8660. So theta is equal to, okay, so shift sine, shift, that's cos, shift sine, 0.8660. Close her off, hit it in, and we should get pretty close to 60 degrees. So 59, 59, 60 to nearest degree, that's just 60 degrees. Okay, question 6 is continuing on the same path, except this time we've got fractions. So theta is just equal to tan -1 of a half. So theta is equal to, and so same thing again, shift tan of 1/2 equals 26 degrees 33. So that's going to go to, oh, it's asking us for 2 decimal places for this case. So this one's going to be 26.57 degrees. So 26.57 degrees. So even though it's still a decimal, okay, we're still trying to find an angle. So when it's asking for it in decimal places, okay, so you leave this one here, but your unit is still the degrees. Okay, this one here, same thing. Going to do the inverse cos, but we're going to do the square root of 3 over 2. So theta is equal to shift cos, okay, square root of 3. Now, if you're just going to put it straight in like this, you have to press the arrow across. Otherwise, the fraction won't work properly, and it'll put the whole fraction inside the square root. Close off the brackets, and we get 30. That one's nice and easy. 30 degrees. Then we've got question 7, which is when to actually solve the triangles. So question 4, you just have to pick what you do. Question 7, you actually have to solve the triangles, like we did up here. So with that being said, that's it for this one. I'll see you guys in the next video.